So I want to start this off by really understanding what is a logarithm, and we abbreviate logarithm by saying it's a log, but logs are just the shorthand version of saying a logarithm. But what is a logarithm? And I think that when we start with logarithms, we're going to start thinking about these things called what powers. And the way that I phrase this what power is what power of 2 is 8. And so I can really rewrite this problem. What power of 2 is 8? And this becomes a much more simple problem. 2 to the third power is 8, so a 3 would go in the box, and a 3 is the answer to this what power problem. Again, what power of 3 is 9? So what power of 3 is 9? And obviously 3 times 3 is 9, so 3 squared is 9. So what power of 3 is 9? The answer would be 2. And what power of 10 is 1,000? Again, what power of 10, 10 to the what power, is 1,000? These are much simpler questions to answer. Turns out to be 10 times 10 times 10, so 10 to the third power is 1,000. Now, what is a logarithm? Well, a logarithm is exactly the same as a what power. So we could rewrite each of these what power problems as a logarithm. So this what power of 2 is 8, we could say, oh, that's log of 2, log base 2 of 8, and it has the same answer. It's 3 because all it is a what power. What power of 3 is 9? It's log base 3 of 9, and the answer is 2. Same as the what power problem. What power of 10 is 1,000? We can write it log base 10 of 1,000 is 3. So we're thinking about these logs as log base 3 of 27. Again, all this is a what power problem. So it's what power of 3 is 27. Well, 3 times 3 is 9. 9 times 3 is 27. So 3 to the third power is 27. Log base 3 of 27 is 3. Similarly, 4 to the what power is 16. 4 to the second power is 16. So log base 4 of 16 is 2. This last one's a little bit more tricky because it still is log base 10 of 1/1000th is what? So it's 10 to the what power is 1 over 1,000. And in class we've talked about if I want to make a denominator, if I want to make something that is just a number into a denominator, the answer here has to be, the exponent has to be a negative number. So we're going to start with that. We're going to start, oh, I know it's going to be a negative. And the negative only turns it into a fraction. So it's negative 10 to the third power because 10 to the third power is 1,000. So 10 to the negative 3 is 1 over 1,000. So the answer is negative 3. Now we can convert forms, and I'm going to show this to you here at the bottom. If I have log of some base power there of a number x equals some value y, I can rewrite this in an exponential form. I think b to the what power, or my answer, is x. Last but not least, we want to think about logs. In Algebra 2, we think about logs, but we don't always notice that we don't always write the base. All of these logarithms are missing a base. So when they're missing a base, naturally the base is 10. So all of these are log base 10. Well, log base 10 of 100, 10 to the what power equals 100. The answer is 2, so log base 10 of 10 is 2. I bet you can do this one on your own. And log base 10 of 3. Now, we don't really have a tool for doing log base 10 of 3 in our heads. We just don't know. So we're going to have to use a calculator for this. Log base 10 of 3, or just log of 3, ends up being this decimal 0.4771. And I always go out at least 3 decimal places. In this case, I went out 4. But in class, we talked about, log, we can interpret this inside as log of 3 times 1,000. And we remember that log of 1,000 is 3. So this is really log of 3 plus 3, because a log of 1,000 is 3. And that ends up being 3.4771. So long as I'm given log of 3, I can figure out log of 1,000. There will be other videos that help us understand this concept a little bit more, but our major understanding should be of the logarithm.